All right, in this video on setting up and solving trig equations, I'm just going to walk through 3 more examples. You can fast forward and just kind of see what the answers were to check your work if you went ahead and tried these on your own, or if you felt like you were needing some more instruction, then you can go ahead and watch this video from start to finish. So in example A, when I look at the fact that I was given this 40-degree angle here, and I look at the information that was given to me, I was given the side opposite of 40, and I was given the adjacent side. So when I think about my SOHCAHTOA acronym, and that I see that I have the adjacent and the opposite side, and the opposite side is what I'm solving for, I see that I need to use the tangent ratio. So I have the tangent of 40 equals the opposite side, which is my x, over the adjacent side, which is 2. And then we learned how we could turn that left side into a fraction by placing the tangent of 40 over 1. And then this is a proportion, so I can cross multiply. And so 2 times the tangent of 40 equals x times 1, which is just x. So I already have x by itself. So all I need to do at this point is just put 2 times the tangent of 40 in my calculator to see what that equals. And once again, we're going to round our answers to the nearest tenths, or one place past the decimal. And so when I do that, I get x equals 1.7. And really, you shouldn't say equals. I should say x is about 1.7 since we did round and we're given approximate answers. All right, in part B, I was given the 45-degree angle. And so if I think about the side opposite, so the side that I'm given is opposite, so I'm going to put that. And then the x is the hypotenuse. So when I think about my sine, or when I think about which trig ratio to use, I see that I have the opposite over adjacent, which means I have to use the sine ratio. So the sine of 45 equals 6, the opposite side, over the hypotenuse, which is x. Put this over 1, cross multiply. I have x times the sine of 45 equals 1 times 6, which is 6. And then divide by the sine of 45. And I would get x equals 6 divided by the sine of 45. That's an exact answer. I want an approximate answer. So when I do 6 divided by the sine of 45, we get about 8.5. Now, I'm curious if any of you noticed something special about triangle B. I noticed it right as I was beginning to solve it, but I wanted to show you the trig ratio, but I also want to know if any of you thought or recognized that triangle B here is actually a 45, 45, 90 triangle. And so this is where, if you recognize that you have those special right triangles, you don't have to use trig to solve them. If I have a 45, 45, 90 triangle, I know the legs are the same, so I know that this leg would have been 6, and I know that the hypotenuse is the leg times root 2. And so I could have just said that my answer is 6 root 2, and if I wanted to take 6 root 2 and approximate it, I would still get 8.5. So if you recognize those special right triangle relationships, use them if you think that that is easier than setting up and solving with trig ratios. All right, let's look at our last one. Our last one, we have an angle that's 20 degrees, and when we think about the sides that are given, we have the adjacent side and the hypotenuse side, which means I have to use the cosine ratio. So I have the cosine of 20 degrees equals the adjacent side, which is 15, over the hypotenuse, which is x. I'm going to put cosine of 20 over 1, and then cross multiply. So I get x times the cosine of 20 equals 15. Divide by the cosine of 20. These cosine 20s will divide to 1. And so we're left with x equals 15 divided by the cosine of 20, which if we put that in our calculator, (15 divided by the cosine of 20) is about, now the answer we get is 15.96. The 6 would make the 9 round up. The 9 would then make the 15 round up to the next whole number. So really x was about 16. So there are 3 more examples that y'all have for setting up and solving trig equations where you're finding a missing side. In our next video, we're going to look at what would we do if we need to find angles, because we're not given any angles of the triangle and all we're given are the sides.